Hi, it's Jo Karen Hudson. We're continuing on Module 14 with Section 14.3. We're going to be talking about more on multiplying and simplifying radicals. First of all, let's multiply. The square root of 7 times the square root of 5 would give us the square root of 35. And then we're going to distribute the square root of 7, and the square root of 7 would give us minus, and I can either write the square root of 49, or I can just write 7. The square root of 7 times the square root of 7 gives us the square root of 49, which then turns or reduces to 7. So this would be the answer to the first example. Example 2. We'll want to FOIL this out, and I'm going to write everything down. You may not need to write every step down, but I'm going to since I'm trying to explain it to you. So I'm going to do the first 2. I'm going to FOIL it, doing the first 2 square roots of 3 times 3 square roots of 2. And then I'm going to do the outside terms. That would be plus 2 square roots of 3 times negative the square root of 7. And then I'm going to do the inside terms, which would be plus 5 times 3 square roots of 2. And then I'm going to do the last, so I'll have 5 times negative the square root of 7. So now I'm going to multiply my 2 times 3 and get 6. And then I'm going to multiply my square root of 3 times my square root of 2, and I will get the square root of 6. Then multiplying a positive times a negative will give me negative 2. And when I multiply the square root of 3 times the square root of 7, I'll get the square root of 21. Plus 5 times 3 will give me 15 square roots of 2. And when I multiply positive times a negative for that last, I will get negative 5 square roots of 7. And that is all I can do with this problem. There are no like terms. There are no radical parts that are the same. Example 3, I'm squaring 2 minus 3 square roots of 7. So I'm going to, means when I square something, it means to multiply it by itself. So I'm going to copy that down. And then I'm going to multiply the 2 times the 2, and I will get 4. And then I'm going to multiply the outside terms together. Give me plus 2 times negative 3 square roots of 7. And then I'm going to multiply the inside terms together. And it will give me positive 2 times negative 3 square roots of 7. And then I'm going to multiply the last terms together. That will give me negative 3 square roots of 7 times another negative 3 square roots of 7. So I have 4. When I multiply positive 2 times negative 3, I will get negative 6 square roots of 7. And again, positive 2 times negative 3 will give me another negative 6 square roots of 7. Then when I multiply negative 3 times negative 3, I will get positive 9. And the square root of 7 times the square root of 7 will give me the square root of 49, or I can omit that step and just put 7 times 7, so that I will have 4. And when I add negative 6 square roots of 7 and negative 6 square roots of 7, I'll get negative 12 square roots of 7 plus 9 times 7, which is 63. So finishing this problem up, this is all I can do. 63 plus 4 is 67 minus 12 square roots of 7. I cannot combine my 67 and my 12 because the 67 does not have a radical part with it, so they are not like terms. I'm going to FOIL this last one. These are called conjugates. And you remember the outside and the inside terms are going to drop out when we have conjugates, but I'll go ahead and multiply it and show you. The square root of 3 times the square root of 3 would be the square root of 9, which would just equal to 3. The outside would give me negative 5 square roots of 3, and the inside would give me positive 5 square roots of 3, and the last Positive 5 times negative 5 would give me negative 25, and these two actually do drop out, so that I have positive 3 minus 25. Positive 3 and negative 25 would give me negative 22. Okay, we'll review just a little bit on rationalizing the denominator. Remember, the square root of 3 is irrational, and we want to replace that irrational number with, we want to replace it with a rational number. We don't want to leave a radical. We don't want to leave that radical in the denominator. So that radical part is the square root of 3, so I'm going to multiply the top and the bottom, or the numerator and the denominator of that fraction, by that irrational part, the square root of 3. And that would give me 2 square roots of 3. And then we have the square root of 3 times the square root of 3, which is equal to the square root of 9, or just 3. Now, we did this in Module 10, but we did not rationalize the denominator when we had a variable in the denominator, but we do it the exact same way. We're going to multiply the numerator and the denominator by that square root of n, so that we will have 6 square roots of 5n over the square root of n times the square root of n. You don't need to put this step. It would give you the square root of n squared, which just becomes n. That step does not have to be put down. Remember that when you multiply 2 square roots together, it just turns out to be n. So we have completed that second example. Example 3, the square root of 5xy squared over the square root of 7. Now the square root of y squared, if I want to go ahead and take care of that immediately, the square root of y squared, I could bring that out as a y square roots of 5x over the square roots of 7. And then I will have to rationalize the denominator by multiplying the numerator and the denominator by that square root of 7. So now we'll have y, the square root of 5x times the square root of 7 would be the square root of 35x. And when I multiply the square root of 7 times the square root of 7, I will just get 7, so that I have completed that third example. On my fourth example, hopefully I will notice right in the beginning that I can divide 5 into 15 and simplify that problem a bit to start off with. 5 will go into 15 3 times, so I will have 3x to the 6th, y to the 14th over the square root of z. And then I should also notice that this is a square root and that these variables will come out even. So I think I'll go ahead and take those out and reduce this to, let's see, the square root of 3 will have to stay on the inside of the radical, but I can divide 2 into 6 and x cubed will come out. I can divide 2 into 14, y to the 7th will come out. I will still have that square root of z in the denominator, square root of z in the denominator. So I want to get rid of the radical in the denominator, so I'm going to multiply by the square root of z, both the numerator and the denominator by the square root of z. Then I will have x cubed, y to the 7th, square roots of 3z. And then in the denominator, the square root of z times the square root of z would be the square root of z squared, which would just equal to z. So I have completed that example. Now moving along to where I have a sum in the denominator, 2 over 2 plus the square root of 3. Now I will need to multiply the numerator and the denominator by the conjugate of 2 plus the square root of z, which is 2 minus the square root of 3. 2 minus the square root of 3. So when I multiply, I'll have to distribute the 2 with both of these. 2 times 2 would give me 4, and 2 times negative the square root of 3 would give me negative 2 square roots of 3. And then in the denominator, I will have 2 times 2 is 4. The outside and the inside are going to drop out. If you want to skip that step, on the outside I will have negative 2 square roots of 3. On the inside I will have positive 2 square roots of 3, and those will drop out, and I can omit that step if I want to. And then for the last, I will have a positive times a negative, which is a negative, and the square root of 3 times the square root of 3 would equal to the square root of 9. I can omit that step and just put 3. So now I have 4 minus 2 square roots of 3 over 1, or I could just rewrite that as 4 minus 2 square roots of 3. In this denominator, I have a difference, and so I want to multiply by the conjugate, which will be a sum. I will be multiplying by 7 plus the square root of x, by 7 plus the square root of x. So in the numerator, I will have 2 square roots of 5 times 7 would be 14 square roots of 5 plus 2 square roots of 5 times the square root of x would be 2 square roots of 5x. And in the denominator, I will have 7 times 7, which is 49. The outside and the inside are going to drop out. You do not have to put that step in there if you realize that they're going to drop out. One of them would be plus 7 square roots of x. The other would be minus 7 square roots of x. And the last would be a negative times a positive, which would be a negative. And the square root of x times the square root of x just gives us x. These drop out. So I have 14 square roots of 5 plus 2 square roots of 5x, or over 49 minus x. And that will not reduce. Our last problem, 17 plus the square root of 3 over 4 minus 5 square roots of 2. I will need to multiply by the conjugate of 4 minus 5 square roots of 2. It will be 4 plus 5 square roots of 2. 4 plus 5 square roots of 2, and I'll have to be very careful on this because there's a lot to do on it. So I will start off 17 times 4 is 68. The outside would give me 17 times 5, which is 85 square roots of 2. The inside would give me plus 4 square roots of 3. And the last would give me plus 5 square roots of 6. In the denominator, 4 times 4 is 16, and I think I will just omit the step of writing the conjugates because they are going to drop out. Writing the outside and the inside term, they are going to drop out. And I'll just do the last, which would give me negative 5 times 5 would give me negative 25. And then the square root of 2 times the square root of 2 would give me the square root of 4, which would be 2. So I have 68 plus 85 square roots of 2 plus 4 square roots of 3 plus 5 square roots of 6 over 16 minus 50, which would be 68 plus 85 square roots of 2 plus 4 square roots of 3 plus 5 square roots of 6 over negative 34. I can leave the answer like this. Some books do not like for you to leave a negative in the denominator of a fraction, but we don't care if you do it, and the computer doesn't care when you put it in the homework if you do that. So I am going to frame my answer in. You will need to do the homework on section 14.3 and the quiz on section 14.3. This is Jo Karen Hudson. Thank you and have a wonderful day. Let me make my smile a little bigger.